the business as usual is the top blue path. We seem perhaps to be on the orange path, which is 3 degrees Celsius warming. The magenta path below it is 2 degrees. I think we're probably too late to do that. Unless, again, these did not take into account taking carbon out of the air and putting it back in the ground. So actually, I would not rule out 2 degrees Celsius warming. But if we didn't take carbon out of the air, I think you could rule out 3 even. So these are assuming no emissions from permafrost or seabed methane hydrates, nor lag warming from vanishing ice and sulfates, nor warming so energy out equals in, nor lag warming from vanishing ice on Greenland and Antarctica. We're already past the 3 degrees Celsius track. Again, we have to take carbon out of the air. That's the only way forward. World CO2 emissions from fossil fuel, the most recent year we have data for from the U.S. Department of Energy. And miscellaneous Asia, a whole bunch of countries, mostly in the China and to some degree India sphere of influence. The problem my brother had when he was giving his lectures in Sri Lanka, told me about, is 4 countries think we created the problem, we have to fix it. More recently they realized we can't fix it on our own and they have to chip in too. They do want us to pay money to help them cope with the consequences. And I think there's a certain amount of justice in that. China's made major commitments to reduce their CO2 intensity, but much more important than that, China's coal use has fallen rather rapidly. Their CO2 emissions have also fallen. As a result, world CO2 emissions leveled off in 2014. IEA has more recent data than US DOE. China's CO2 emissions, I'm pretty sure, peaked in 2013. They committed to peaking by 2013, or 2030. I think they peaked actually 17 years before they promised to. China is who's made solar energy dirt cheap. And I think India is going to be recognizing that. India is the last major holdout in doing what needs to be done.
Maybe it should be added that if emissions level off, the amount of CO2 is just continuing to rise.
That's right.
We're not
you got a
leveling off the amount
three-part
of
thing.
CO2.
First, you level off your emissions, decrease them. Eventually, you get your CO2 level stabilized, but the temperature continues to go up. So you have to reduce your CO2 levels, which means you have to go carbon negative to limit your temperature rise. So it's a kind of 3-part thing. These are individual areas and countries. You look at them on your CD. U.S., the electricity has leveled off consumption over the last 10 years. Coal's share of U.S. electricity has had ups and downs, but has been on a clear downward trend for almost 30 years now. Oil imports are down steeply. Oil use in the U.S. is down modestly, uptick this year because of low prices of gasoline. And U.S. CO2 emissions up and down, but they're down roughly 12, maybe 13% over their peak in 2007. You have oil use pushing them up, but coal use is pushing them down this year. U.S. sources of electricity, coal for 2015, I only have 4 months of data on 2015, so I haven't put that on there. The coal is down to about 35% in 2015. Natural gas is headed up, nuclear is pretty much the same. Wind power is rising pretty strongly, although it's kind of leveled off this year. This production tax credit is up in the air a lot. Solar is going up a lot, but it started from a much lower base than wind. Ooh, that turned out poorly. Basically, there are a lot of ways to make electricity. The major things are use less coal, use oil and gas, especially gas, mostly for going with jiggling loads. The potential for wind energy is more than enough to supply the entire United States. Solar energy potential is enough to supply the United States many, many times over. With the cooling demands in the United States, solar is a very good match time-wise for that. You still have to worry about seasonal storage and heating places at night and winter. Nuclear power can be useful for that. Your other alternative is to overbuild your wind capacity quite a lot and have some of it be idle other parts of the day. Geothermal in the west, but that's probably not very much of an option around here. There are other things like geothermal, ocean power, wood, water. Water power, hydroelectric is going to get less because there will be less stream flow. You're seeing that already at Hoover Dam, Boulder Dam, and Lake Mead. What we can do in buildings, at home, heat pumps. We just got our heat pump installed about 6 weeks ago. We're probably going to cut our propane use by about 90%. Still use it for water heating and cooking. We do actually do most of my cooking with microwave oven, 100% wind power through renewable energy credits. Insulate the house very well. Insulate your house very well. Honeycomb window shades on all your windows. Make R5, even R6 windows. It's an important part of what we do and have done for a long time. Yeah, you can buy them as window treatments, Home Depot's where we got ours. And you just pull up and down, and a lot of cells interlocking kind of like this. And they provide about R3. You roll them up and down depending on conditions. You have double pane glass with low E coating, so that's about R3 on the glass plus R3 from the window shades, about R6 windows. Personal vehicles, we can do a huge amount there. Some of you are already doing it. You can use a car unless you need a van or pickup truck for work. SUVs, I really can't see any reason to use SUVs. They're the devil's creatures as far as I'm concerned.
Increase the growth rates against them.
Yeah. We're hoping to get an electric vehicle in 2018 when we have one that goes 250 miles. It doesn't cost $80,000, it costs $30,000. I think you may see a very rapid transition once that happens. I'm expecting that in 2018. That's about the same time I'm expecting the Supreme Court to okay the Obama's regulations on CO2 emissions from power plants, which is about the time the Republicans want a deal on a carbon tax. I don't think they're going to deal before then, but they're going to deal very rapidly. Move from the impossible to the inevitable in the space of 3 months. On personal level, things you can do, many of you are probably already doing these things. Make your home office efficient, don't oversize a house. That was my first audience was energy engineers. They didn't worry about oversizing and supersizing. Let's take off on McDonald's, actually, French fries. But don't idle unless you really need to. Buy things that last and get them fixed when they break. Walk. Jane and I walk a lot. It's a great thing. I recommend it highly. You may want to eat grassland beef because they're going to be working on absorbing CO2 and putting it in the soil. But stay away from feedlot beef. It's unhealthy among many other things. Ask Congress to price carbon, cut CO2 emissions 80% or more by 2050, and take carbon out of the air. So, I'm sorry if I've gone on too much. There's scads more material on the CDs. I have those CDs on the table for those of you who didn't get one, or for those of you who know people that you can give copies to, in addition to the copy I gave you for your own use. There are a bunch more back here. And a few more back here. And let me take questions for about 5 minutes, maybe 10 minutes, and then I switch over to Shelley and Chris, and then we'll switch back to me for more questions on my talk. Roger.
Very thorough summary on the carbon question. to broaden the strategy, is it possible to consider sort of a cloud seeding or volcano-based questions in NASA to put up small reflectors to reflect a little bit of the sunlight and reduce the temperature?
Yes, it's possible. You can sow the stratosphere with sulfur. I've seen projections for doing that as low as 10 billion a year, but I think 40 billion a year is a better estimate. Sulfur will fall out, and we'll probably get about 10,000, maybe 40,000 people dead per year as a result of sulfur falling back to Earth. But that's reasonably small compared to the death toll from being hotter. The problem is you have to keep on doing that. Pardon?
Maybe they can develop a different material.
Well, you can make cloud contrails, increase cloud cover, and I feel more positively about that way. There's also putting mirrors in space, but you got solar sails and they tend to drift away. But you have to keep on doing those, and it doesn't change what's happening with acidifying the oceans, and therefore what happens with the oxygens, Earth's oxygens.
As part of a comprehensive strategy.
But we don't know about natural Earth cycle.
You were going to ask me.
It seems to be a reality.
Well, we're doing engineering in a very major way right now with carbon dioxide. Yeah, we do know they'll shift rainfall patterns quite a lot. Sulfur in the stratosphere, we learned a lesson in Cuba. Yeah.
The only line slope that changes every second.
Right.
Talks about all of these silver bullet fixes, and this sucks them all very nicely. But like with the chargings of carbon, you can only apply the laws in the United States, and more companies gain their way around that immediately, so that if you really want to apply it, like,
Well, that's why
have any effect.
you can charge the price differential at the border, so it will not disadvantage so much with jobs, but you're right. But there's huge momentum around the world for doing this. Japan, 28% reduction. EU, around 30 to 35% reduction. China is going to vastly overperform what they promised. They're already doing better than what they promised they have done 17 years from now.
Okay, I have a couple of questions. One, I'm Mark Coward from Valley Hill.
Yeah.
A couple of questions. One is, Toyota has recently been used being bashed a bit because they're not embracing lithium-ion battery technology like used in Tesla. They're instead going to introduce all these cars powered by fuel cells, which
Right.
are already being criticized as not being a step forward.
Well,
And such. And I think that might be to keep their gasoline engine business going well, because that's where they have to leave. I would like your idea on that. And the other one is I do a lot of shortwave broadcasting and radio stuff. What can you say about the Belgian minimum and the sunspots and the sunspot relationship to cooling?
okay, so we got questions. One about fuel cells as an alternative to battery-driven cars. The second one about the sunspot cycle, a modern minimum, perhaps a brand new minimum coming up, and what effect that might have. So about the fuel cells, if you make the hydrogen and have a good safe place to store the hydrogen, as long as you're separating water into hydrogen and oxygen using wind energy or another renewable energy, especially good for wind energy, I can see some future. The energy density of fuel in fuel cells is higher energy density per pound than you would get from lithium-ion batteries. And I think they're thinking range, and it might wind up going that way. Maybe have to gauge a market. I know Nissan and Honda are working with them on that. The Japanese government is really throwing major support behind that. Most of the rest of the world, though, is lithium batteries. And lithium-ion batteries are becoming cheaper. Of course, you've got the Gigafactory by Tesla outside Reno, Nevada. And there's a new process that I just read about a couple days ago that may be able to cut the cost of that in half. I think the weight, in order to have enough kilowatt hours to go 250 miles, you probably need about 900 pounds of batteries, and that's not negligible. You can put that between the axles and mostly on the undercarriage, and you can do it, but there is a certain weight cost to doing that, and the equivalent weight of gasoline is more like 50 pounds, 75 pounds to go that same, 50 pounds probably go that same distance. You do need to make the vehicles very efficient, and there's a lot of wastage in those vehicles. But, you know, we get 45 miles per gallon with our gasoline cars, so, you know, it's, and the US as a whole gets like 20. So there's a lot of room just to be more efficient. But I'm betting that batteries will have more market share than fuel cells.
Well, they're using to embrace the lithium-ion batteries. They use NIMH.
Oh, that's pretty old.
And so they're just gonna go straight from the NIMH type battery, straight into the fuel cells, and that's what they're being criticized for. They're not embracing lithium-ion, because they don't want to test it. We want to go to some other.
The marketplace will determine the mix of those two technologies. Okay, solar changes. There have been periods since we started watching sunspots, very shortly after 1600, where virtually no sunspots appeared. The longest and biggest of those was the Maunder minimum from about 1645 to 1712. We have I've seen records of sunspot numbers from 1700 to 1712. They weren't always zero. Some of the numbers were higher than what we had 3 years ago. We were a pretty low minimum, probably about the lowest in 100 years, 3 years ago. So the effect of a grand solar minimum is detectable among the noise, but it's not a lot bigger than the noise, and it's pretty small compared to the signal from greenhouse gases. So if we had, say we had another Maunder minimum without sunspots for 70 years, the temperature rise by the end of the century, instead of being 4 degrees Celsius, might be 3.6 degrees Celsius. So it's not negligible, but it's fairly small. By and large, the temperature changes by about 0.1% from the sunspot maximum to the sunspot minimum. And that's not a very well, the solar energy impacts in the earth changes that much. And it's not really a lot. They get amplified a little bit with what happens with the ozone and the ultraviolet absorbing layer. But even with that amplification, it's not all that much. And it's certainly quite small compared to the CO2 effect, and it's fairly small even compared to the methane effect. Lady in front.
The book shop, economic cost of global warming, came out this year.
Okay.
One of the chapters is about the engineering to shoot particles into the atmosphere.
Yeah.
It seems like that's sort of a new idea.
Well, it reminds me of
Question we can't hear.
engineering to shoot particles into the atmosphere. That reminds me of two things, both of which I addressed kind of with Roger. If you're shooting sulfur into the stratosphere, sulfur is dark, it screens out sunlight. People have looked at that a lot, and there are pros and cons to it. I think the cons outweigh the pros. There's also shooting particles for cloud condensation nuclei in the lower atmosphere, and I think that is sowing clouds, increasing cloud, especially do it from ships, shooting these guns out with things that are cloud condensation nuclei. And I think that's probably lower risk. I don't know any downside in terms of people breathing in sulfates, so you're probably not going to have a death toll of 10 to 40,000 people a year. You have pretty close control of it, clouds will drift some, but not across the entire stratosphere around the globe. It doesn't make the oceans any bit less acid, and it doesn't mean that we don't have to take static carbon out of the air, but it can ameliorate things a little bit, I think. One more question here, and then let me turn it over to Chris.
Do you think we should be more concerned about population growth?
Oh, yes. That's one place where I think the Pope did a wonderful thing with this encyclical, with the blind spot is that you have probably too many people on Earth. If we all had the lifestyle of the average person in India, we could support 10 billion people. If we all had the lifestyle of the average American, we could support maybe 1 billion people. And you know, the number of wild creatures, the population of wild creatures, animals, has been cut in half in the last 40 or 50 years. And most of that is growth of human population expanding into the wild areas and taming them for our use. So there are a lot of big problems with population growth. If you had 1 billion people at the Indian style of living, and we took 100 billion tons of carbon out of the air and put it back in the ground, I think we would do quite nicely. The wild animals would be very happy with us.
The COP also addressed consumerism or capitalism, I think is what he addressed. And many of us believe that infinite growth on a finite planet is impossible.
Yeah.
We have a consumer mentality third world countries. What's your take on these comments there?
Well, infinite growth on a finite planet is impossible. It's the philosophy of the cancer cell. And, you know, we need to
address it in a culture like ours.
It's tough. It's a long-term transition. Let me turn this over to Chris. More questions, and Chris and I can take more questions after it's finished.
Hello. My name is Chris McNamara. I am a member of the Fayetteville chapter of Citizens Climate Lobby. I want to thank Gene for that nice presentation. Thank you for having us. What I want to do is talk to you today about some of the solutions we can use to address this climate change disaster that we're facing, and something specifically that we can do right now. Gene mentioned carbon pricing. A lot of economists and scientists think this is a really good method for us to take action right now that will have significant impacts in reducing our carbon emissions. What I want to talk to you about specifically is carbon fee and dividend. And this is a policy that is being proposed by the organization I'm with, Citizens Climate Lobby. It's a very simple policy, very transparent, straightforward, and it has a lot of benefits to it. So I'm going to lay that out for you, tell you a little bit about our national organization, our local chapter, what we're doing, and if you have any questions, I'd be happy to answer them. So carbon fee and dividend is pretty simple. We put a fee on the CO2 content of fossil fuels at their point of entry. So that is the well, the mine, the port into our national economy. We, in this policy, start that fee at $10 per ton of CO2 content for fossil fuels. We steadily rise that fee $10 per ton every year. What this does is it gives a clear market signal to the industry and investors that the cost of fossil fuels is going to go up. The cost of low carbon intensive production is going to go down. So it presents for them a steady place for them to invest in. The revenues that we get from that fee, we take 100% of that and we return it back equally to the U.S. citizens in the form of a monthly dividend check. We had a study done, and I'll talk to you about that in a second, that showed...
What starting point did you say? What was the starting point that we...
So we have a fee, the starting point is $15 per ton. We raise $10 per ton each year. So it's steadily rising. We return that revenue that we collect back to U.S. households. We do this to protect the family budgets, to prevent those rising energy costs, commodity costs, from, making people poor. Our study that we had done commission shows that 2/3 of the households will actually come out with more money from that dividend than they get in increased energy costs and commodity costs. So Citizens Climate Lobby has this proposal. We think really highly that it's going to go somewhere. So we had a study commissioned on it. That study was done So that study was done by a DC economic forecasting firm called Regional Economic Models Incorporated. They took our policy and did a 20-year study on it. And what it found is that with carbon fee and dividend, we can reduce CO2 emissions by 33% in just 10 years, and by 52% in 20 years. This is faster than any of the other methods that we currently can tell. We also create 2.1 million jobs in 10 years, 2.8 million in 20 years. By recycling that revenue back to everyday citizens, they spend it in the economy. We have this consumer economy that helps us grow. We save 13,000 lives annually. That's 227,000 lives in 20 years. We increase the GDP by $70 to $80 billion each year. Within 20 years, that's $1.3 trillion. So what this is showing us is that we can use a market-based solution. It's very simple to reduce carbon dioxide emissions quickly and help protect our economy and even make it grow. So this is CCL's policy that we're presenting. CCL is a national organization of volunteers. It's a grassroots organization. There's only 6 employees. There's currently 16,000 volunteers. 2 years ago, there was only 1,000. Last year, there was 5,000. This year, there's 16,000 members. So it's growing drastically. There's a lot of momentum. And what CCL's main goal is to create the political will to address climate change. We have this policy, so we're going out, we're presenting this to the community, we're doing outreach, we're building our coalitions, we're writing letters to the editor, we're creating the dialogue, moving the dialogue forward about climate change. And also, we are directly lobbying our members of Congress. I know Shelley briefly mentioned that. And that's a really big thing. We're showing that we care enough about this to go out and meet them where they are and talk to them.